We have integral of rational function. Let me copy our rational expression. We have t to third power plus t square plus 2t plus 1 over t square plus 2 times t square plus 1. We can rewrite this that this is identically equal to, because t square plus 2 we cannot factorize and t square plus 1 we cannot factorize, so we have to put in denominator t square plus 2 and t square plus 1, and because we have in denominator t square, so we need to put in numerator a times t plus b, and in the second numerator we will have ct plus d. Now, to reduce this fraction, we will multiply both sides by t square plus 2 times t square plus 1. So when we multiply left side by this whole expression, denominator will reduce, so we have only numerator t cube plus t square plus 2t plus 1 is identically equal to, and now we have to multiply over right side every fraction by this expression. So when we multiply first expression by this, t square plus 2 will reduce and we will have only at plus b times t square plus 1. Plus, and the second expression when we multiply by this whole expression, denominator will reduce and we will have ct plus d times t square plus 2. Now we have to do multiplication on the right side, so left we will copy is identically equal to, and now we have to multiply at times t square is at cube. Now we have to multiply by 1, so it will be plus at plus bt square plus b, and we have ct times t square, so it's ct cube plus 2ct plus dt square plus 2d. Next, we have to combine like terms. So we have a t cube and ct cube. So let me copy left side. T cube plus t square plus 2t plus 1 is identically equal to t cube. We will factorize and we will have a plus c. Next we have to put t square, so we have plus t square times b plus d in parentheses. Next expression with t will be, so we have at and 2ct, so it will be in parentheses a plus 2c, and constant is b plus 2d. Next, we have to compare the coefficients of t cube on both sides. So we have t cube, coefficient before t cube on the left side is 1, so we have 1 should be equal to coefficient before t cube is a plus c. Next we have to compare the coefficients of t square. T square, we have 1 on the left side, and on the right we have t square times b plus d, so we have b plus d. Next we will compare coefficients of t, so we have 2 is equal a plus 2c, and constant, we have 1 on the left side is equal b plus 2d. Next, we will find a from the first equation. So a is equal 1 minus c, and we substitute a in the third equation by 1 minus c. So we will have that 2 is equal 1 minus c plus 2c. So we have that c is equal 1. When we have c, we can find a. A is equal 1 minus 1 will be, so a is equal 0. Next, we will find b from the second equation. B is equal 1 minus d. So now we substitute to the fourth equation b by 1 minus d. So we will have 1 is equal 1 minus d plus 2d. So we have that d is equal 0. When we have d, we can find b. b will be 1 minus 0 is 1. Now we can come back to our partial fractions and we will rewrite our integral to sum of these partial fractions. So we have this is equal integral of, and in parentheses we will have a t. A is 0, so first expression we reduce, we have only b is equal 1, so it will be 1 over t squared plus 2. Next, we have plus c is equal 1, so we have t over, and d is equal 0, so we don't have to write, and we have t squared plus 1 with respect to t. So this is equal. We have integral of sum, so this is equal sum of integrals 1 over t squared plus 2 dt plus integral of t over t squared plus 1 dt. For first integral, we will put that t is equal square root of 2 times u. Why I put square root? Because I need to factorize 2. So next I will have to find derivative of both sides with respect to t. So we have 1 is equal square root of 2 du to dt. Now I will multiply both sides by dt. So we have that dt is equal square root of 2 du. So now we can do substitution for the first integral. This is equal dt is equal square root of 2 du. So we will have in the numerator square root of 2 du over, and we will have t is square root of 2 u. We have to second power plus 2. And we have plus. In the second integral, we see that we have, when we take derivative of denominator, we will have t squared plus 1 derivative is equal to t. And we have only t in numerator. We need this 2 to use formula that integral of f of t prime over f of t is, with respect to t of course, is equal natural logarithm of absolute value of f of t plus constant c. So to use this formula we need to have 2 in numerator. So let me put this 2t, and now because we have at the beginning only t, so I will multiply this by 1/2. 1/2 times 2 is 1, so it's the same what we have at the beginning. We have only 1t. And the numerator we have to rewrite, so we have t squared plus 1 with respect to t. So this is equal. We can take this square root before integral symbol. So we have square root of 2. And we have du over square root of 2 to second power. So it will be 2u square plus 2. And we have plus 1/2 I will take before integral symbol. So we have now in numerator 2t over t square plus 1 dt. So this is equal. In the first integral, we will factorize 2 in denominator. So we have square root, we have to copy of 2, and we have integral of du over 2 times u square plus 1 plus, and now we have 1/2. In numerator we have derivative of denominator, so we will use this formula. So we have natural logarithm of absolute value of t square plus 1 plus constant c, of course. So this is equal. We can take this constant before integral symbol. So we have square root of 2 over 2. And we have integral of 1 over u square plus 1 du plus 1/2 natural logarithm, and we have t square plus 1. T square plus 1 is always positive. So we don't need this absolute value bars. We will put this in parentheses, t square plus 1 plus constant c. And now we know that 1 over u square plus 1 is arctangent of u. So this is equal square root of 2 over 2 arctangent of u plus constant c1. We can put plus, we have 1/2 natural logarithm of t square plus 1 plus c. So this is equal. Now we have to come back to substitution. We have that t is equal square root of 2 times u. So to find u, we will divide both sides by square. Let me copy this. We have t is equal square root of 2 times u. Now we divide both sides by square root of 2. So we will reduce square root, and we had that u is equal t over square root of 2. So now we will come back to our substitution, and we have square root of 2 over 2 arctangent, and we will have t over square root of 2 plus, next we will put expression with logarithm. So we have 1 over 2 natural logarithm of t square plus 1, constant c plus c1, so I can put c2. This is my solution.